Okay, so we're going to continue with our lesson from class. Examples 3 and 4, again, ask us to find the derivatives of these functions. So we can go ahead and differentiate number 3, f prime of t using quotient rule. So that's going to be low, which is t squared plus 4, d high, the derivative of the top function is 2, minus high, which the top function is 2t, d low, the derivative of the bottom function is also 2t, all over low, which is our denominator quantity squared. Okay, so I want to simplify what's in the numerator now. So when I distribute 2 over the first two terms, that gives me 2t squared plus 8 minus 2t times 2t gives us 4t squared. All over t squared plus 4 quantity squared. Okay, so we want to continue simplifying our numerator, so I can combine like terms. So 2t minus 4t squared is negative 2t squared plus 8 over my denominator, which is t squared plus 4 quantity squared. Okay, so I can factor a negative 2 out of the numerator. And when I do so, that leaves me with t squared minus 4. And then t squared minus 4, that's the difference of two squares, so I can factor that to be t plus 2 times t minus 2 over t squared plus 4 quantity squared. All right, and that right there is our derivative simplified completely. Okay, I want you guys to try 4. So go ahead and pause the video and do number 4, and then we'll talk about it together. All right, so with 4, I'm going to guess most of you working this through use quotient rule for this, and it's fine. It's not the way that I would do this, but quotient rule can work for you. So that's going to be low, d high, the derivative of the top function 1 is 0, minus high, d low, the derivative of the bottom function is 2x, all over low, which is x squared squared. So that's going to make f prime become negative 2x over x squared squared is x to the 4th power. And then we can cancel a factor of x in the numerator and denominator. So that's going to simplify to negative 2 over x cubed. All right, so that's one way to take that derivative. Now, the way that I would advise, which would make things a little bit easier, is you can take that function 1 over x squared and rewrite it as x to the negative 2 power. And then you can use power rule to differentiate that, which is going to make f prime equal to negative 2 times x to the negative 3rd power, which you can rewrite then as negative 2 over x cubed. So you get the same derivative either way. I think just the way we worked it out in purple on the right is a little bit faster, a little bit more efficient. Okay, on to our last two examples. So the directions here say to find the equations of the lines tangent to and normal to the function y is equal to rad x over x plus 1 at the point 4, 2/5. All right, so with this example here, the first thing we have to check is we have to check to see if this point is on the graph of our function. And the way we do that is by plugging the x-coordinate 4 into our function and to see if it gives us a true statement. If that point is on our graph, that's great. It makes the problem easier. If it's not on our graph, like we work through examples in both sections 4.1 and in 4.2, like what happens when our point is not on our graph, like that process becomes a little bit more complicated. So I'm not going to work through that here because we check if we plug 4 in the place of x, we get the square root of 4, which is 2, over 4 plus 1, which is 5. So that point 4 comma 2/5 is on the graph of our function because it gives us a true statement. Okay, so we want to go ahead and the point that we're given here, that is our point of tangency. So if we want to find the equation of the tangent line, we need to find the slope of the tangent line, which means we need to find the derivative of our function. All right, so our derivative, y prime, I'm going to use quotient rule for. So that's low. That's a bottom function, x plus 1, d high. So if I want to take the derivative of rad x, I can write that as x to the 1/2 power. Again, the derivative of that is going to be 1/2 x to the negative 1/2 power, which I can rewrite that as 1/2 times x to the negative 1/2 is 1 over x to the 1/2 power. 1 over x to the 1/2 power is 1 over rad x, and when I multiply those two things together, we get 1 over 2 rad x. So that's going to make the derivative of the top function become 1 over 2 rad x. Minus high, so that's rad x, d low. The derivative of the bottom function is 1, all over low, which is going to be x plus 1 quantity squared. Okay, so we get y prime here equal to x plus 1 over 2 rad x minus rad x all over x plus 1 squared. Now, you can go through and simplify this derivative if you want. And the way you would do that would be to multiply the numerator and denominator by the common denominator of our smaller fraction, 2 rad x. But you don't need to simplify the derivative here because we're trying to find the slope of the tangent line, which means we want to evaluate this derivative at 4. So when I plug 4 in the place of x, 4 plus 1 is going to make that smaller numerator 5 over 2 rad 4, which is 2 times 2, which is going to be 4, minus rad 4, which is 2, all over 4 plus 1, which is 5, and 5 squared is 25. So if we want to simplify that complex rational expression, we're going to multiply the numerator and denominator by 4. And then when I distribute in the numerator, 4 times 5 over 4 is 5, minus 2 times 4, which is 8, all over 25 times 4, which is 100. So that makes y prime equal to negative 3 over 100, which makes the slope of the tangent line negative 3 over 100. My point of tangency is the ordered pair 4 comma 2/5. And then I can plug that info into my point slope formula. So my point slope formula is going to become y minus the y coordinate 2/5 equal to the slope negative 3 over 100 times x minus the x coordinate 4. And that right there is our tangent line equation. Okay, the slope of the normal line. So we know the normal line is perpendicular to the tangent line at the point of tangency. So that means the slopes are going to be negative reciprocals of one another. So the negative reciprocal of 3 over 100, of negative 3 over 100, the negative reciprocal of that is 100 over 3. And then the point of tangency is exactly the same. It's the ordered pair 4 2/5. So that's going to make the equation of the normal line, y minus 2/5, equal to the slope of the normal line, which is 100 over 3, times x minus the x coordinate 4. All right, on to the last example. So the directions here ask us to find the equation of the line tangent to the function f of x, which is 3 minus 1 over x, divided by x plus 5 at the point negative 1, 1. Okay, so again, first thing we want to check here, does this point lie on the graph of our function? So when we plug -1 in the place of x, it hopefully will give us an output of 1. So when we plug -1 in the place of x, we get 3 minus 1 over -1, which is -1. 3 minus -1 is the same thing as 3 plus 1, which makes the numerator 4. The denominator is going to be -1 plus 5, so that denominator becomes 4 as well. So that is 4 over 4, which is equal to 1. So that checks out. That's great news. That tells us that the point -1, 1 is the point of tangency. We want to find the slope of the tangent line at -1. So to figure that out, we need to find the derivative. But with the way the function is written right now, like the derivative using quotient rule is going to get a little bit messy with this here. So I'm going to make things a little bit easier algebraically for myself by multiplying the numerator and denominator by x, which is going to get rid of the fraction in the numerator. Okay, so when I distribute x across the numerator, that's going to make the numerator become 3x minus 1. And when I distribute x in the denominator, that denominator is going to become x squared plus 5x. And I think multiplying the numerator and denominator by x is actually going to give me an easier function to find the derivative of. Okay, so we're going to take the derivative of this function using quotient rule. So f prime is going to be low, which is x squared plus 5x. D high, the derivative of the top function is 3, minus high, so that's 3x minus 1. D low, the derivative of the bottom function is going to become 2x plus 5, all over low low, which is x squared plus 5x quantity squared. Okay, now you can do like what you did in the previous example. Like if you want to evaluate this derivative here at -1, that's fine. There's nothing wrong with that. Okay, you'll be able to determine the slope at -1. The other option is for you to simplify the derivative and then evaluate the slope at -1 whenever you simplify the derivative. Okay, so since I didn't work the previous example out in that way, I'm going to go ahead and work this one out in that way. Again, if you want to evaluate the derivative at -1 in this step right here, that's perfectly fine. Like there's nothing wrong with that. Okay, I'm just not going to do that in this particular case. So when I distribute 3 across the first two terms, we get 3x squared plus 15x minus, and then I'm going to FOIL out 3x minus 1 times 2x plus 5. So when I do that, 3x times 2x, that becomes 6x squared. 3x times 5 is 15x. -1 times 2x is -2x, so 15x minus 2x is plus 13x. And then -1 times 5 is -5. All over x squared plus 5x quantity squared. Okay, so I'm going to distribute the negative across all three of these terms here. And then I'm going to combine like terms in the numerator. So when I do that, we get f prime equal to 3x squared minus 6x squared. That's -3x squared. 15x minus 13x is plus 2x. And then the opposite of -5 is positive 5. And we're going to take that and divide it by x squared plus 5x quantity squared. Okay, so I'm going to go ahead and evaluate that derivative now at x is equal to -1. So f prime of -1 is going to be Negative 3 times negative 1 squared. So negative 1 squared is 1 times negative 3, that's negative 3. Plus 2 times negative 1. That's going to be minus 2. Plus 5. Which is going to give me my numerator, and then when I plug negative 1 in the place of x in my denominator, we get negative 1 squared, which is 1. 5 times negative 1 is minus 5. 1 minus 5 is going to be negative 4, quantity squared. That numerator becomes 0. The denominator is 16, which makes the slope of the tangent line 0. Okay, so the slope of the tangent line is 0, and then it passes through the point negative 1, comma 1. Well, if the slope of our tangent line is 0, that means that our tangent line is a horizontal line, okay, which means the tangent line is going to be y is equal to some number. And for that line to pass through the point negative 1, comma 1, that means the y-coordinate of our line has to be the same as the y-coordinate of our point. So that means that our tangent line is going to be the line y is equal to 1. Like if you wrote that in point slope form, you could do that as well. You would get y minus the y-coordinate 1 equal to 0 times x plus 1. On the right-hand side, that multiplies out to 0. So you get y minus 1 is equal to 0, which makes y equal to 1. So you get the same equation for the tangent line either way. All right, so that's it. That wraps up section 4-3. Again, make sure you guys have your homework assignment done before you come to class on Wednesday or Friday, depending on what period you have me. All right, so that's it. Hope you guys have a great rest of your day.